Hello everybody, this is lecture 8 of the course Introduction to Electric and Electronic by Mr. Amr Abdul Bari. Today I will speak about voltage divider and current divider. Beginning with the voltage divider, as we see before, there is a series circuit, parallel circuit and series parallel circuits. So the voltage in the series combination of resistance is divided and you see different voltage across each resistor. So we use the series circuit as a voltage divider, so it's an important application of the series circuit. Now let's see how we calculate the voltage across each one. We use the same equation as we used it before, but in a different way. Let's see. If you see here, we have a voltage source and different resistors. So we use here from R1, R2, R3, R4, each one see different voltage. So if you have Vx, which is the voltage across the resistor X, and Rx is the value for this resistor, then as we see before, the current that come across series circuit is the same in all resistors. So Vx is equal to the I, the current, multiplied by the Rx. Now this I is equal to what? It's equal to the total voltage over the total resistance. And the total resistance in the series circuit is calculated by a summation of all resistance from R1 to Rn, whatever the number of resistors. Okay, so if you substitute this equation in the previous equation Vx, then we have Vx equal Vs over Rt, the R total, multiplied by the value of this resistor. If you take this outside, the voltage, and this is inside, then you have something else. You have Rx over Rt multiplied by the Vs. Vs is the V of the source, the total voltage. Then you have this ratio of the resistor that you want to calculate the voltage drop across this resistor, over divided by the total resistance. This is the value for Vx, the value of the voltage divider. This is the equation. Okay, so now you see here, if I have three resistors, then Vi is R1 multiplied by the current, which is the same, or R1 over R total, sorry, multiplied by V total. V2, it is the same, you can calculate it using the Ohm law, R2 multiplied by the current, or R2 over the total value, R1 plus R2 plus R3 multiplied by the V total. The same idea for these three. A numerical example, he gives you here the value for each resistor, and he asks you to find V1 and V4. So V1, that's come the voltage here in the R1 and the voltage here in R4. Okay, so you just calculate all the value to get R total, and then for the V1 you have already V total or the Vs, R1 over all the numbers of all the value. See here that 1k, it is 1000, 2k it's 2000. Remember that. So you will substitute all the values, very easy, you get the final value of 1.5. For V4 it is the same, but you will just remove the value for R4, it's 6000 or 6 kilo ohm. You see, you remember that all the voltage are V1, V2, V3, V4. If you take a summation, you take the summation of all of them, they should be equal to the v total. Remember that if you calculate all of them and you find that all of them it's higher or lower, then there is a problem. Okay, and take a hint for the polarities. Okay, you see the polarities. Now to the second part, the current divider. The current divider means that I see in the parallel series, parallel circuit, I see different current in each branch. Yes, so the current is divided. The total current is divided across the branches. Okay, so let's see here. I have 1, 2, 3, 4 here branches. I see different current in each branch, but the same voltage across all of them. The same voltage that come from the source, it is the same. So the Vs is the same. So now Ix, this is the equation for current divider, but we will try to see how we get this. R total over the Rx plus R total multiplied by the I total. Okay, let's see how to get this equation. Now the current that come across this one, for example, it is how much it is the v total over this value over rx, the v total over rx. So here we have it using ohm law. Now how much the v total, let's see how much the v total, it's the I total, I current, the total current, total value of current multiplied by the total value of resistor. Yes, yes, we have this. So let's take this vs and put it in the other here. So let's see, I total multiplied by R total over Rx. Take this inside and take the I from outside. So we have Ix is equal to the R total over Rx multiplied by the I total. So here it's reversed, and if you remember the equation for, or the formula for the voltage divider, you see Rx, the target resistor over the R total. Here it's the reverse multiplied by the total current from outside. Okay, so example, here we have the equivalent value for the equivalent resistor for the two resistor. It's R1 multiplied by R2 over R1 plus R2. So you take this and multiply it by the I total, you get V. Yes, and we want, this is the V total, we want what, we want the I over the R1. So we take R total over, or V total, this V over R1. Yes, you see that R2, this is I1, this R2 over R1 plus R2 multiplied by I total. Okay, so this is this difference. Now here, let's see here, R total here over Rx, R total over Rx. Okay, so alternative way is to use the conductance. If you remember, the conductance is 1 over the resistance. So this is the conductance equal to, yes, this is the conductance, it is 1 over R. So if you take it 1 over R, then you will see the it's the same equation like the voltage division or the voltage divider. The the targeted G is in the numerator and the total G is in the denominator, multiplied by I total. Okay, now let's calculate this equation. Let's see here. So R2, R3, you take this equation for the current division principle for two equations here, these two equations. Let's see here, R equivalent over R1 plus R equivalent, so RIS. So you calculate using the same values. I think the values here is mixed. Okay, but you can see in your book some examples here, reworking with the calculation using the G. So G1 is 1 over R1, G2 is 1 over R2, G3 is 1 over R3, and here I1 is the portion, this is the ratio of G1 over all of them multiplied by the IS. Then you have getting here the same value, yet like you take it here or you get it here using the resistor. Okay, there is this is the general equation divider. Here we calculate a special equation for the two resistor equation using the R equivalent for the two resistor. Maybe we can use the general equation that we calculated before, this general equation for the two resistors here, for the two resistors only. So R total is R2 R1 R2 slash R1 R3. Okay, so I will use I1 is R total over R1, and R2 is R total over R2. It is the same idea. You will see that this is will get the same equation because here you put R1. So in I1 you will see R2 over R1 plus R2 multiplied by I total, and here you see in the numerator R1 over R1 summation with what, with R2. Okay, this is a special case, that's why we name it, but the same idea is for 100 200 equivalent resistor, or 2 3 3 4 6, whatever the number of the equations. This is when we have here R2 will go with the R2. Okay, so this is very easy. Thank you for listening.